Hello, Happy New Year and welcome to this January 2012 edition of the Cambridge Café Scientifique podcast, sponsored by the Medical Research Council. I'm Mira Senthilingam from thenakedscientist.com. This month, as many of us try and burn off that extra weight from the festive season, obesity expert Dr. Laura Heisler from the University of Cambridge was on hand to explain the physiological mechanisms behind weight gain and why this weight gain to the extent of obesity has become more common in recent years. Laura's work looks into whether drugs could be developed to stop people eating more than they should. And when talking about her work, she started with a worrying insight into the current obesity situation.
Obesity is a huge problem at the moment. It actually reflects one of the major economic and medical challenges of the 21st century. A large proportion of people in the UK and in the developed world are obese. What happens when people become obese is it strains the system, and when the system is strained, lots of things start to go wrong, and people develop disease. In addition to just straining joints and things like that, you may actually start to develop disease, such as cancer, heart disease, stroke, type 2 diabetes, etc. And what then happens is that obviously then the individual's sick, but then they have to go, then they're going to the hospital, and then that puts a real burden on the hospitals, as well as their cost implications with people being in hospitals all the time and requiring treatment.
Do you have any figures at all as to just how big a problem it's become, say percentages of populations?
Yeah, about a third of the people in the United States are obese, and in the UK it's about a quarter of people, so 1 in 4 people are obese, but the rates of overweight are even higher, with approximately 60% of women in the UK are currently overweight, making the UK actually the most obese nation in Europe, unfortunately.
Gosh, so we should certainly be worried, but hopefully you're here to help. What have you been looking into with regard to obesity?
What we're trying to do is we're trying to understand how body weight is becoming dysregulated. So why are people becoming more obese? This is a problem that's developed in the past 100 years. Obviously, one of the major differences between 100 years ago and now is that we have cars. We can call for food. There's takeout. We don't actually have to walk or ride a horse from one town to the other. Things are immediately delivered to our doorstep. We can do all sorts of our shopping. Instead of dragging bags around for Christmas, we're actually able to order things online. So it just causes us to have a much more sedentary lifestyle. And so what we're trying to understand is that balance between ordinarily what's supposed to happen is when we expend less energy, we're supposed to eat less food. So it's an energy balance. So our expenditure and our intake are balanced together so that we don't gain weight, so that we're in a neutral energy state. But what's happening is we're having a reduction in our expenditure, and we're also having an increase in our intake because there's a mass availability of highly palatable foods. So as researchers, what we're trying to do is we're trying to understand specifically how is appetite and energy balance regulated in our bodies, in our brains, so that we can tap into this system to try and help us correct it.
And so what have you been able to see so far? How does our brain, say, control our eating habits perhaps, or our hunger, or is that what you're looking into?
Exactly. The easiest thing to do is to just tap into the energy intake component of the equation, to get people to take less food in. And we're built to survive. We're built to adapt and to survive. And so there are going to be lots of redundant systems that make sure that we eat. But unfortunately, for us, that's no longer adaptive, because we actually don't need to have all of these additional systems driving us to eat, because we actually have lots of food readily available. So what we're doing is we're defining all of these different pathways in the brain and in the body, and trying to understand how they interact, and trying to understand which are the principal ones so that we can target those principal pathways and suppress appetite that way.
And what are the principal pathways? I think you've managed to narrow down to a few, haven't you?
Certainly one thing that we know is from drugs that have already worked in the past to treat obesity. And some of those drugs augment serotonin, which is a neurotransmitter. They augment serotonin bioavailability. And so by increasing serotonin levels, people suppress their food intake and reduce weight. And drugs targeting the serotonin system have been in the treatment of obesity for about the past 15 years. Unfortunately, serotonin is really important in lots of things, all of our instinctual drives. And so what's happened is that we've gotten some off-target effects that have also come into play, and it's caused the withdrawal of those drugs from the market. So one of the things that we've been trying to do in my lab in particular is we've been trying to understand how the serotonin system acts to suppress food intake, to try and dissociate the clinically desirable effect, suppressing food intake and body weight, from the off-target effects. And one pathway that's really important that serotonin acts through is the melanocortin pathway. And that pathway appears to be a really critical gateway through which a lot of hormones, the hormones are released from the gut, hormones that are released like insulin, blood glucose. When we eat, our nutrients are also detected by these melanocortin neurons in the brain. And so these melanocortin neurons serve as a principal and fundamental gateway through which energy balance is modulated, both hunger and fullness.
So your aim would be to get into this pathway and prevent it or stop it?
Exactly. So what we want to do is we want to hijack the pathway. We want to take those neurons and turn them on to suppress food intake and suppress body weight and to reduce hunger. So that's what we want to do. Now, there's some difficulties with targeting that pathway directly. Unfortunately, the drugs don't appear to get into the brain. So then drug companies have been looking into, well, how can we get them into the brain? One possible way would be a nose spray. So there's some creative thinking that's going on there, trying to figure out how we can tap into this particular pathway.
And so where are we now? What do we perhaps need to do next to really try and get to that end stage of having these drugs available?
One of the things that we have to be aware of and thinking about is that, as I said, we are built to survive. And so because of that, we do have these principal pathways that we're going to try and as I said, hijack. But there are so many redundant pathways that are going to say, hey, wait a second, I'm losing weight. I need to survive. This is going to be bad. What if there's a famine? So then other pathways might kick in. So what drug companies are doing now is they're thinking about, well, which are the, say, 2 or 3 principal pathways, and can we target both of those at the same time to try and override this sort of drive to feed that we end up having.
And I guess an important point would be to really only target those that are truly obese rather than it becoming, say, just a weight loss pathway target.
Oh, definitely. This is only as a clinical problem. The easiest way to lose weight is to just increase energy expenditure. I know it's not interesting going to the gym, but if you think about 100 years ago, we didn't go to the gym. We actually walked to work, or our work involved physical activity. Pharmacotherapy is only really for the clinically morbidly obese, where obesity is a medical problem, where obesity is life-threatening. And that's when you need a drug. Drugs are not for people who can get to the gym and exercise.
Laura Heisler from the University of Cambridge. Now, the topic of obesity is always in the public arena, with many curious about the causes and nature of the condition. Audience members on the night certainly reflected this curiosity, starting with a query about whether thirst and hunger are controlled by similar mechanisms.
Is there a strong link between thirst and hunger? Well, there certainly is a link between thirst and hunger, but there are slightly different pathways that are regulating thirst and hunger. So there are pathways in the hypothalamus, there are pathways in the lateral hypothalamus in particular. But when we give drugs, for example, in the clinic or in the laboratory, and we look at drugs that are reducing food intake, they don't tend to also reduce water intake or liquid intake. It seems to be specific to food. So that sort of illustrates that there is a dissociation, but of course they are linked.
People also wondered why some appear to put on weight more easily than others, despite eating the same amount of food.
So can people who have the same energy intake store it differently and gain weight differently? What happens if it's not being stored? It's really simple. There's just an energy balance equation. The balance is, if someone's storing it, then they're in a positive state of energy. They're storing the energy. And if another person is taking the same amount of food in and they're not storing it, they're expending it. right? Whether they're expending it because they're fidgeting. That was a really cool paper that came out about 5 years ago maybe, where they actually found that a lot of lean people just fidget. They're shaking their leg while they're sitting still, they're tapping their pencil, they're always sort of moving and expending energy. Whereas the people who tended to store weight, very serene. They're listening, no moving. So, and we had people in our office who did that, and it was quite funny to observe when the paper came out. They were saying, yes, this is definitely true. So it can be expenditure, but it can also just be basal metabolic rate as well. So some people just have a higher metabolic rate than other people, so they, that's just generation of heat. So, yeah, so that's just, that's just another sort of endogenous factor. But likely is that these are all due to individual variation. And in addition to that individual variation is that you have people who just are more susceptible to having an increase in appetite, to having a reduction in a fullness. So again, these genes give us ideas about what's happening in the normal variation in humans, how different genes are contributing to different behaviors.
Many in the audience were sceptical about resorting to drugs to deal with what could be considered a social problem.
So how do I respond to people who say we should use drugs or even surgery to respond to a problem that's just evolved in the past 40 years? I think it's a good point. It's also a complex point because, as I said, our environment has dramatically changed in the past 100 years. We don't have to exercise anymore in our day-to-day life. And as animals, we're meant to expend energy, take it in, expend it, take it in, expend it, etc. We're meant to have this continuum. And without it, what happens is we end up with a perturbed system. Then our bodies adapt to that perturbed system. So by having an excess and an excess and an excess, as I said, with leptin, you end up getting an insensitivity to signals. And so it actually becomes quite complex. And so I don't want to say that excess in adiposity or excess in food intake or having that extra glass of juice a day or something has anything to do with morality or frailty or anything like that. It's just something that our environment has changed. And with that, because we're built to survive, we're built to have these drives for feeding, it's quite hard to overcome them. So the best thing to do is to not use drugs, is to not use surgery, is to prevent obesity from happening. So to get exercise back into the regime, to get exercise, back into schools, to make it much more of a lifestyle in this country, in the world, where we are exercising as part of life. And then everything's equal, as it was 100 years ago. So that's the main thing that's changed, well, in addition to food being more readily available.
Because so many factors play a role in our appetite, sight, smell, hunger pains, metabolism, one audience member was curious how all these different drivers are regulated.
So what are the specific pathways that are regulating the different drivers for feeding? There are different drivers for feeding, and so what we've been trying to, yes, there are different ones. There are hedonic ones, there are homeostatic ones. They have to talk to each other. Food has to be rewarding, otherwise we wouldn't eat. So lots of things that we do are rewarding to encourage us to do them. That's how we've been built. So they're going to talk to each other. We have something that's called the dessert effect. The Monty Python sketch of one wafer thin mint, in addition, after having a huge meal. We often say, oh, I couldn't eat another bite, and then someone brings out a delicious dessert, and you say, well, I could probably manage it now, or I'll split it with you. It doesn't count if it's splitsies. We do have other systems that play in, and they are mediated. The smell goes in a different way, but what we're looking for when we're looking for ways to understand energy balance, to understand appetite, we're looking for the principal mediators. And what's really surprising is that we do have principal mediators like the melanocortin system that are integrating so many of these signals. But yeah, I mean, your chemoreceptors and the stretch receptors in your gut are very different than then your olfaction system and your visual system, they're all different, but they are all going into the brain. They're all acting in a pathway that ends up going through either homeostatic or hedonic networks, which then feed back out and get us to walk to food. We have to initiate movement. We have to chew the food. So there will be common pathways that are being engaged.
And with obesity being such a recent problem, scientists themselves are curious about what factors in modern life are playing a role in its growth. And one person in the crowd suggested it was our dependence on central heating during cold weather.
Definitely. That is one of the theories for the rise in obesity is the advent of central heating. Because now we all are very comfortable and we don't need to expend energy. We're not shivering and expending energy to stay warm. We're just constantly in a state of thermoneutrality. And so we're not getting that extra benefit of expending energy just by having cold. It's a hypothesis of something that's changed in our environment in the past 40 years that could be a contributing factor.
And what about changes that happen in our bodies as we age, causing so-called middle age spread?
So the middle age onset weight gain, that again, we're talking about a lot of times. Then we're just talking about the old energy balance equation. When you're young, you tend to move around a lot more. You have a lot more that you're doing and that's going on. As you get older, you start to work in a job where you don't need to move as much. You're not going out as much. You're not doing as much, and so the energy expenditure decreases. But we do have people with mutations that are consistent with that as well, that give us insight into the pathways through which that's happening. And it's actually one of the pathways that I study, which is the serotonin pathway, which does feed through the melanocortin pathway. But the serotonin 2C receptor, those mice that have a mutation in the serotonin 2C receptor, they overeat their whole life, but they don't start to gain weight until middle age. And it is a very perplexing question as to how they're able to be normal weight, throughout their entire development and into early adulthood. It's a question because they're overeating, and they are also they are overactive, but the obesity doesn't come until later. So it's an open question, but we've got a receptor candidate in mind, and we'll see.
As we've heard, there are many drivers involved with obesity, and one anxious member of the audience was keen to know whether another driver, perhaps helping fight obesity rather than cause it, could be anxiety.
It's a really good question. Are anxiety and appetite linked? Yeah, undoubtedly anxiety and appetite are linked, but we've got some complexity there. So just like depression and anxiety are linked, depression and appetite are linked, what happens is some individuals have an increase, respond by being depressed or anxious by having an increase. Some people respond by having a decrease. So it's not the same. There can regularly be a dysregulation, but oftentimes what people respond to for therapies for anxiety and depression are drugs that increase the bioavailability of serotonin. So Prozac, Zoloft, those types of drugs. And what serotonin, by increasing serotonin, what we do is we also influence appetite. And so one of the questions that people have is, well, how come all these people who are on antidepressants and anti-anxiety drugs, how come they're not all losing weight? And the answer is probably because in those individuals, they have a dysregulation in the system to begin with, which causes the primary clinical observation, which is the anxiety or the depression, and what the drugs do is they correct it. So in some individuals, you would end up anxiety, eat more, some people eat less, some people fidget more, lose weight. They're all really complex conditions that have lots of contributing different factors. But it is an interesting question and one that's being researched in our department.
Laura Heisler from the University of Cambridge. Now, after the event, as usual, I spoke to some people in the audience, all of whom were very slim, I noticed, and I heard their thoughts on the talk, but also their views on the issue of obesity.
The injunction to exercise more just seems so sort of simple, almost too simple to be true. But nevertheless, Laura seemed to insist that that was sort of the best way, the best initial basic approach to not developing obesity. And I mean that's cultural as well, isn't it? It's very cultural. I'm old enough to remember when all schools had their own playing fields. They don't. Everybody had to do some PE, I would say several times a week, in all weathers, whether you liked it or not, whether you were interested or not, you just had to do it. So I think she's absolutely right in saying that on a day-to-day basis, in the past, people used to just take much more exercise without even thinking about it. Everything involved exertion. And now that's simply not the case. And she impressed on us what a huge issue it is.
It was interesting to hear about the different models. I thought she presented very well and made it very interesting. So I definitely enjoyed the talk.
And what are your thoughts just generally then in terms of dealing with obesity today?
I thought the speaker made a very good point about increasing our energy output, and that really it is just a balance that we need to maintain.
I had a fair idea that it was quite a big problem. I didn't realise that it was 1 in 2 people that were overweight in the country. That was quite surprising.
And what about the topics discussed this evening to do with it? So I guess what some of the causes and ways to avoid it. What did you think of it?
It was interesting, one of the questions about central heating. Maybe we could also reduce our carbon emissions and obesity at the same time if we were to turn down our thermostats.
Well, it is quite a mild winter at the moment, so you're just going to turn your heating off?
I've got a very cold house, so turning my heating off would be a bit extreme, but I'm tempted to minimise the time that I've got it on at the moment.
So some change might just result from Laura's wise words. Now, that is it for this month's podcast. But if you'd like to attend a Café Scientifique yourself, the next event will be on Tuesday the 7th of February at Baruch Bar in Cambridge. Details of the speaker can soon be found online at cambridgecafescientifique.com. The Triple Helix Cambridge Café Scientifique is sponsored by the Medical Research Council, and the website is brought to you by rabbitholedesign.co.uk. And this podcast was produced by me, Meera Senthilingam, from The Naked Scientists.